off your puss, Gordy. Fletch and I call this huddle to talk about a popular summertime service, engine tune-up.
Tune-up? You mean long trip get-ready?
No, Gordy, not that by itself. Tech and I want to talk about how we can be more thorough on ordinary run-of-the-mine tune-up work. When we are more thorough, we get more thoroughly satisfied customers. Customer satisfaction, of course, is the key to increased labor sales and sweet music on the cash register.
You covered the point very well, Fletch. Gordy knows what to do about valves, points, plugs, timing, and carburation. The usual tune-up operations. It's those little extra touches we had in mind.
Maybe I'm a little thick, Tech, but I still don't get it.
Well, that's not your fault, Gordy. But take the Plymouth Fury V800 engine as an example. If one comes in for a tune-up, be sure to read the speedometer mileage. If it reads 12,000 or so, it's time the valve tappet clearances were inspected. Then, by checking specifications in the shop manual, you'll know that intake valve clearances should be set at 10 thousandths. Exhaust valve clearances set at 18 thousandths, both settings made with the engine running at normal operating temperature.
10 and 18. Well, I think I have been doing that. Did I slip up on a Fury job somewhere?
No, Gordy. We're just trying to point out extra operations that can be sold at certain times. Things the owner should have done that will give him better performance and economy.
Yeah, here's another example. Sometimes the high-tension cables need an especially close inspection. Engine heat plus cold winter temperatures expand and contract the insulation so much tiny cracks and pinholes may develop. Distributor cap and spark plug terminals also can corrode and cause poor contact, the same as any electrical connection that's dirty. Cracked cables and corroded terminals just don't contribute to good ignition. So, remove the cables for inspection and be extremely careful how you remove them. Hold the cables at the insulating covers and pull straight. Examine them for cracks and tiny pinholes. In addition, make sure the terminals are clean and tight. If there's any question about the condition of the cable, test it for leakage. If you have no way of testing for leakage, the best thing to do is to replace the cable.
Say, anytime you replace cables, be sure you use the same type you removed. Don't ever wind up with a combination of non-resistor spark plugs and non-resistance cable.
You can get spark plug cable sets from the parts department, and for non-resistor plugs only, there's a new resistance type cable package.
Okay, I'll keep that in mind.
And here's something else. If the insulating sleeves and covers that fit over plugs and distributor cap towers get brittle or cracked, they should be replaced.
Boy, you really want us to be thorough.
Well, it pays off, Gordy, as you'll see. Now, don't forget to see that the distributor-to-coil wire is of the resistance type on all Chrysler Corporation-made distributors.
I remember, Fletch. It's marked radio.
Loose or corroded terminals in the primary circuit are items sometimes overlooked, Gordy. Looseness and corrosion add resistance to the flow of primary current, which causes hard starting when the engine is cold. A voltage drop test should be the first step in locating a condition of that kind. When the point of resistance is located, that connection should be cleaned and tightened. Now, when you suspect an electrical condition as being the cause of a can't start case, make a voltage drop test between the switch side of the ballast resistor and the battery post. If voltage drop is no more than 0.2 of a volt, test voltage drop between the distributor side of the coil and ground. Now, if there is more than 0.1 of a volt drop, look for a poor connection between there and the distributor, for burned points, or a poor ground.
When you mentioned burned points, Fletch, I got to thinking about the slight buildup of metal that takes place.
Oh, yeah, Tech. I'm glad you reminded me. When metal builds up on either point, it's usually a result of the type of driving being done. So don't jump to the conclusion that the condenser is at fault. Test the condenser instead, and replace it only if it fails the test. Replacing a condenser unnecessarily causes the owner unnecessary expense. Now, if the points are set too close, they'll burn and pit. The different types of burning that take place can spell out other corrections that should be made.
Points burned black usually mean lubricant got on them. It could come from the cam surface or the felt in the center of the cam.
Points burned blue mean excessive voltage. The voltage regulator is probably set too high, is damaged, or improperly adjusted, and should be tested.
Will do. Now, what's another good extra touch to include on an engine tune-up?
I'd vote for the air cleaner, my boy. That's missed so often it's a wonder that it gets any attention at all.
Oh, Tech's so right. That oil bath cleaner should be serviced every 1,000 miles. If there's a collection of dirt or sludge, the filter element should be removed and swished around in kerosene. The reservoir should also be cleaned and fresh oil added. Inspect and clean the dry type air cleaner every 5,000 miles. Replace it every 15,000 miles on a car driven normally, that is. And when you clean the dry type filter element, blow it out with compressed air from the inside out. Don't put the nozzle too close to the element or it might be damaged.
How about tapping the dirt out?
Well, tapping can damage the element before all the dirt is jarred out. Compressed air does a much better cleaning job and is easier on the element. Don't forget to wipe out the filter chamber. After all, you know that a partially clogged air cleaner will cause a carburetor mixture that's too rich. It not only wastes fuel, but top speed performance is seriously affected. And don't forget to clean the filter in the oil filler cap and the filter in the crankcase ventilator pipe if one is used. Also see that the ventilator pipe is free from any restricting dirt. Unless both ends of this ventilating system are open, the crankcase will sludge up and collect excessive acid.
Okay, Fletch. I'll see that the engine gets good crankcase ventilation.
Fine. Now, inspecting drive belts and their tensions also belongs on your must-do list. On cars with power steering, drive belt condition is vital. A loose belt leads to erratic steering, noise, and even lack of assist on some occasions. A belt that's frayed or glazed due to slippage should be replaced right away. And tighten a belt to the tension specified for used belts. After all, a belt is considered used once it's been operated for longer than 15 minutes. Use a torque wrench or the deflection method to get the proper belt tensions. You'll need the torque wrench adapter on 55 and 56 models. Later models have a square hole in the pump mounting bracket that fits the torque wrench drive. Now, if you use the deflection method, be sure to use a spring scale and a 5-pound pull. Leaning your thumb on the belt just won't work. All specifications, by the way, are spelled out in this reference book.
That'll be a help, Fletch. I'll be sure to use the right belt tensions.
Good. Now, let's look at the cooling system. Antifreeze left over from winter, of course, must be drained. The practice of some owners who leave it in and just add rust resistor should be discouraged.
And when you drain antifreeze, Gordy, be sure to push the temperature control lever to hot. That opens the water control valve and lets antifreeze drain from the heater core.
That's a good point, Tech. If the solution you drain is dirty or rust-colored, be sure to use a cooling system cleaner. Then reverse flush the cooling system.
Okay. Clean and then reverse flush the system. Will do.
Don't forget to examine the rubber hoses to see if they've deteriorated. If they're okay, add rust resistor to the clean solution when you refill the cooling system. On air-conditioned cars, remember to add 1 gallon of fresh, permanent type antifreeze when you refill. That'll protect the coolant solution in the heater core when the air conditioning system is working.
Attaboy. And somebody better protect this needle. This side of the record is all played out. Let's try the other side.
Here's another important point to keep in mind. All of our 1959 V8 engines in the United States use a 180-degree thermostat.
Oh, yeah, Fletch. I've noticed that.
Well, we don't want that 180-degree thermostat changed for summer operation. It's designed to let the engine run warmer for greater efficiency all the year round. Carburation is better, and fuel economy is at its peak. But don't forget to inspect the pressure cap. If it loses ability to maintain pressure, summer driving might cause a loss of water and the engine might overheat.
Maybe I ought to test that pressure cap, huh?
Yep. Use this tester with the cap adapter to make sure the cap's doing its job. If the cap fails, replace it.
That cap should hold between 12 and 15 pounds pressure. If the car is equipped with air conditioning, it should hold at least 15 and not over 16 pounds pressure.
That's right, and it's a mighty important point to remember. Use the same tester without the cap adapter to pressure test the cooling system. That way you can tell whether the cylinder head gasket seals properly or if there are any slow leaks at the connections or in the heater core. But remember to test the cooling system at a pressure 3 pounds higher than cap pressure.
Okay, Fletch, will do.
That's fine, Gordy. The manifold heat control valve, I guess we've talked about before, but since it has such a direct bearing on engine performance as well as economy, let's cover it again. It must work freely, of course, so it can help control temperature of the mixture that enters the cylinders. You can test it by hand in a couple of seconds. If the valve sticks in its open position, that's bad. The hot gas will not be directed to the exhaust crossover passage and around the carburetor hot spot to preheat the mixture. Now, if that happens, the engine will idle poorly and the choke will work overtime and just waste fuel.
Yeah, and the owner will be sure to tell us about that.
That's so true, Gordy. And if the valve sticks in its closed position, that's going to upset the air-fuel mixture in another way.
Tech's right. Here's what goes wrong. When the valve sticks closed, too much heat is directed at the carburetor hot spot. That overheats the air-fuel mixture and interferes with proper combustion. There's no pickup, acceleration is poor, and high-speed performance is affected. It stumbles and so on. The choke comes off too soon, percolation often shows up, the engine stalls and may be hard to start again.
Wow, it really compounds the trouble.
Right. But you can guard against that by using solvent every 1,000 miles to make sure the shaft rotates freely. Also, be sure the thermostatic coil spring works properly.
All right. I've made it another must-do inspection.
Good. Now, while we're near the carburetor, let's remember to test the carburetor air horn screws for tightness. Sometimes they work loose and air leaks develop. Now, that, in turn, leans out the mixture and spoils idle performance. If you didn't know those screws were loose, you'd tend to set the idle mixture screw on the rich side to compensate for the air leaks. Economy would sure go out the window. Now, for example, during part and full throttle operation, the throttle valve would have to be opened wider than necessary for a given speed. That's another attempt to compensate for the over-lean mixture. An over-lean mixture can also lead to burnt valves.
Holy cats. And all because the air horn screws are loose.
Right. So, whenever the air cleaner's off for servicing, tighten the air horn screws as well as the mounting stud nuts. Don't overlook tightening the intake manifold attaching bolts either. You'll find torque specifications for them in the shop manual.
Okay. I'll snug those points down on every tune-up, Fletch.
Well, you do that, Gordy. And on high-mileage cars, don't overlook a possible air leak around the throttle valve shaft. Wear on the shaft or in the throttle body, or both, can cause an erratic idle condition. So if you have a case where idle adjustment varies every time you open and close the throttle valve, inspect for excessive clearance at the shaft. You may have to replace the shaft or throttle body and shaft assembly to correct this condition. Now, on 4-barrel carburetors, inspect the secondary throttle valves to see that they work freely. These valves get more of a workout in summer, and unless they're free to move, top speed operation and fuel economy both will be affected. If the secondary valves stick, look for gummy deposits on the valves and throttle body. Use solvent to get the carburetor free of gum.
Very well, Fletch. I'll give those valves the microscopic treatment. What else you got on tune-up?
Well, if you get a report of excessive fuel consumption, along with hard starting, there are a number of things to inspect. Now, for example, choke setting, float level, condition of the needle valve and seat, all affect economy and starting. Now, be sure the choke is set as specified. See that float level is right and the floats can move freely. Make sure the needle valve seats tightly. On cars with the integral type choke, check the index mark on the housing to see that the thermostatic coil spring is properly adjusted. If you find carbon or corrosion in the choke mechanism, the heat tube might be drawing exhaust gases from the manifold. Now, that means the heat tube is cracked, burned through, or has a loose fit in the manifold. This calls for replacing the tube or the manifold and tube as an assembly.
Okay, Fletch. I'll be sure to cover the choke.
Good. Now, poor top speed performance will also be affected by a low float level or poor fuel pump performance. The best way to find out is to test the pump once you're sure float level is okay. Pump pressure should be 5 to 7 pounds at 500 RPM. Vacuum pull should be 7 to 11 inches of mercury at cranking speed. Fuel pump vacuum that's too low tends to starve the engine at higher speeds.
Sometimes it isn't the pump at all. Sometimes the fuel line or hose is kinked and restricts the flow.
Yeah, Tech's right. Always examine the fuel line, hose, and hose connections. At the same time, be sure to service the fuel filter.
Leave it to me, Fletch. I'll take care of those conditions.
That's good. Now, another thing to poke your nose into is accelerator pump position. The stroke is adjustable, as you know, but the middle position is the standard setting for all normal driving conditions.
Okay, middle position. But what happens if it's left in the long stroke position?
Why, the engine's likely to stumble on acceleration because an overly rich mixture shoots into the cylinders. It certainly isn't needed for summer driving, and that extra charge adds up to a lot of wasted gas during a day's operation.
Well, you've sold me, Fletch. I'll be sure to inspect the accelerator pump setting. Frankly, that's one thing I haven't been watching.
Oh, you're not alone in that, Gordy. That's what I meant by all of us trying to be more thorough on tune-up. Now, additional information on the extra touches we've just talked about is completely explained in this reference book.
Good news, Fletch. I'll make like a bookworm and get that thorough tune-up story down pat.
Glad to hear that, Gordy. Extra effort on our part will convince owners to bring their cars to us when they want trouble-free, economical summer operation.